Okay guys, so today we are going to be looking at some inverse trig functions. So we're going to start just with this 30, 60, 90, and 45, 45, 90. Go ahead and fill those in. This is 30, this is 60, this is 90, this is 45, this is 45, this is 90. So just go ahead and fill those in just to review. Okay, and so what did you put across from the 30 side? What do we use there? 60 and 90, 2. And 45, 45, 90, how's it go? Okay, and so we talked about how we could use these triangles and we could actually fit them into the unit circle if we wanted to. The way we could do that would be to take this hypotenuse and turn it into the radius of a circle, and I would need it to be a unit circle. So then I would divide this by 2, and can you see how if I did that, divide that by 2, divide that by 2, this would now turn into 1/2, this would turn into radical 3 over 2, and this would turn into 1. So see how the sine of 30 is 1/2, the cosine of 30 is radical 3 over 2. That's how it's all related. Hopefully now, instead of just memorizing the unit circle, you can almost just visualize these triangles and fit them in there if you needed to. Alright, now looking at this, this is the unit circle. You should know these points, these quadrantal points for sure. This is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. But today we're going to be doing these inverse sine and inverse cosine ratios. Instead of calling this 300 degrees or calling it 5 pi over 3, we're actually going to go in this direction when we're doing these arc sine values that are negative. Instead of calling this 270, we're going to go in this direction. What would this angle be if I start here and go that way? What would we call it? Negative 90, or negative pi over 2, right? So I'm going to name this negative pi over 2. This angle, if I go in this direction, it's a 60-degree reference. So what could I call it then? Instead of negative 60, negative what? Pi over 3. This angle would be what? Negative what? Pi over 4, because it's 45 degrees. And then this one would be called negative what? Pi over 6. Good. And this one is still just going to be 0 radians. When we're doing arc sine and we have a negative ratio, we're going to actually be using these names of 0, negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Let's go down here now. So it says evaluate each of the following. Remember that for arc sine, arc cosecant, and arc tangent, the interval for the answers is going to be in between negative pi over 2 and positive pi over 2. For arc cosine, arc secant, and arc cotangent, the interval for the answers is between 0 and pi. Also, arc sine of 1/2 means the same thing as inverse sine of 1/2. In both cases, you are given a value of the ratio, and you're being asked to find the angle. If you're asked to find the sine of pi over 6, now we're given the angle and we're being asked to find the ratio. People find that confusing, but this means we're finding the angle, those we're finding the angle, here we're finding the ratio, okay? So, up here it says that for inverse sine functions, we're using between negative pi over 2 and pi over 2. What quadrants would that be? 1 and 4, good. We can only use quadrants 1 and 4. And the names we have to use in quadrant 4 are going to be negative angles. In quadrant 1, we're using positive angles, because we're going up. Which quadrants are used for inverse cosine functions? If it's between 0 and pi. 1 and 2, okay? We don't have to ever worry about negative angles when we're doing inverse cosine functions. It's only when we're doing arc sine, arc cosecant, arc tan that we'll ever use negative angles. You guys remember using negative angles for this last year? A little bit. Also for these kind of problems, guys, we're only going to have one answer. That should make things easier if we're only going to have one answer. Because when we're going between 0 and 2 pi and 0 and 360, we had to have two answers, now just one answer. So life should be easier based off of that. Alright, arc sine of 1/2. Our answer has to be in between negative pi over 2 and positive pi over 2. So we're being asked, what is the angle that has a sine ratio of 1/2? You know what the reference angle is there? 30, and so what's our answer? Pi over 6. Should I also say 5 pi over 6? No. This is a function, meaning it's 1 to 1. We have one answer. Inverse cosine of 0. Inverse cosine of 0. I'm looking for one answer. Which quadrants do I have to use for inverse cosine? 1 and 2. So I'm looking for an answer between here and here, where the cosine value is 0. Jocelyn? Good. How'd you know that?
Because the coordinate is 0 and 1.
Right. And cosine is x. Good. Look at the next one. Tangent of 4 pi over 3. Am I trying to find an angle or am I trying to find a ratio? Ratio. You have to understand when you are finding a ratio versus an angle. This one, we're given the angle, find the ratio. What's the reference angle here? 60. Which quadrant? Third quadrant with a 60-degree reference. Radical 3. 1, 2, negative, negative. Tangent. Opposite over adjacent. What's the answer? Radical 3. See the difference? We're finding the ratio.
So it doesn't matter, like, the ratio can be in radians or it can be like an actual tangible number, like 1 over 2?
Sure.
Okay.
The ratio is always, the ratio will never have pi in the answer because it's the comparison between the opposite and the adjacent side. Yeah. All right. Part D, cotangent of 5 pi over 6. Are we finding an angle or are we finding a ratio? Ratio. So ratio answers are like 1/2, 1, 0. All those are ratios. Okay, so 5 pi over 6, what's the reference angle again? 30. We're in the second quadrant, 30 degrees. Label 1, radical 3. This is negative. And now figure out what the cotangent is going to be. What's the cotangent? Negative radical 3, good. So again, that's a ratio. Part E, arc cosine negative 1. Are we finding an angle or are we finding a ratio? Angle, one angle. Okay, so we have to think on that unit circle between 0 and pi. I'm only allowed to use between 0 and pi. You guys know what the answer would be? Pi, yeah. Okay, arc sine negative radical 2 over 2. Okay, think about what we can use. Good job, negative pi over 4 is right. Okay, does that seem familiar to what you did last year? It was probably explained a little differently, but that's how it goes. Alright, let's come down here now. Calculus is not a complicated subject. The part of calculus that's difficult is simplifying. It's like you do these derivatives, you're going to do this integration, and then you look at the answer, and you don't have the right answer. And you think you're wrong. The problem is that you didn't do all the algebra that's necessary. So this is going to be reviewing algebra and how to simplify. Alright, so looking at this, we're going to rewrite as a single simplified expression. Use radical form rather than rational exponents when needed. So what we're trying to do to have something simplified, no negative exponents. That's not simplified when we have negative exponents. Does this 8, that's a factor by itself, does it have a negative exponent? No, it doesn't. This is 8 to the first power. The 8 is going to stay where it is. It's a common mistake that people think the 8 goes with the negative 3 exponent. It does not. So the 8 stays where it is. The x is going to go to the denominator and become a positive exponent. This down here in the denominator, that has a positive exponent, so it's going to stay where it is. And then here's another factor. It's a negative exponent. So to make it a positive exponent, I'm going to take it to the denominator. So this is what I have now. So in the numerator, the only thing I have is an 8. In the denominator, I've got an x cubed, and then I have a 6x minus 1. If I have like bases and I'm multiplying, what do we do with the exponents? Add them. So what power is that going to be to? So first. So I'm just going to have, this is going to be my answer right there. And that's more simplified than that. So if we did a calculus problem, found the derivative, got that answer, we've checked the solutions, and this is the answer. It's just because we didn't simplify. All right, I want you guys now to try letter B. I'm going to be working it up here, but try not to look up unless you get stuck. You get it? Okay. So that 3x is not attached to this factor. This is really 3 to the first, x to the first. That's the only one that has a negative exponent. All right, getting a little bit more difficult now. Now we don't have multiplication, we have addition. And we're trying to get this down into a simplified single value with no negative exponent. This is more difficult. Because right here, this is one term by itself. This is over 1, and this is over 1. So for this one, if I want to get rid of that negative exponent, I have to make it 1 over 6x minus 1 to the 1/2. This one is just going to stay as it is. I'm trying to get this to a single expression. Right now I have 2 terms. I want to have 1 term. So if I have a fraction, just what if I have like 1/3 plus 1/4? If I have 2 fractions, how do I add 2 fractions? Get what? Common denominator, right? So that's what I'm going to have to do here. So this is over 1, but I'm going to have to multiply it by 6x minus 1 to the 1/2 on bottom. If I multiply the denominator, I have to multiply the numerator. So this one, I've just got a 1 plus, what's this going to be now? Just 6x minus 1 to the first. I don't need parentheses if it's to the first power. So I'm just going to write it without the parentheses. And then the direction said to use radical form. So if I have 6x minus 1 to the 1/2, that can be written as radical 6x minus 1. The nice thing about calculus is you never have to rationalize the denominator to have it simplified, so that's good. All right, so what are we just going to have in the numerator now? 6x, and in the denominator we have this. Okay? All right, you guys want to try letter D on your own, and I'll work it up here, and you can look up if you need to. follow that? Is it confusing how I wrote that as the cube root of 2x minus 1 squared? You guys remember how the denominator of a rational exponent tells us the root? Sometimes people have a hard time remembering that. I think roots are in the ground, so the bottom number's lower, so that's the root. Power lines are up in the sky, so the higher number tells us the power. So that might help you. Yep.
Where did the 5x come from? Did you like simplify it?
Well, see, once this was to the first power, then I didn't need parentheses anymore, so 3x plus 2x is 5x. See, when I'm multiplying these two, it's to the first. So once it's to the first, I no longer have parentheses, and I can just combine like terms. All right, so a little more factoring down here. Okay, so when we're factoring, this is just GCF work. That's all it is. So if I have these two, 2u to the 3 halves, 8u to the 1 half, what is the common factor? 2u to the 1 half, great. And so now I have to divide. I've got 2u to the 3 halves divided by 2u to the 1 half. So 2's are going to cancel. What do I do if my bases are alike and I'm dividing? Subtract, so it's going to be u to the first, so I'm just going to put u. Then I have 8u to the 1 half. Hopefully you get to where you don't have to write this, but just at the beginning I like to write it. So what is 8u to the 1 half divided by 2u to the 1 half? 4. And then the directions said to write anything in radical form rather than rational exponent form. The 2 is not to the 1 half, only the u is to the 1 half, and then I've got u plus 4. And this is now in factored form. Okay? If you have strong algebra skills, any math you take in college you'll do fine in. It's the algebra that always gets people, even at really high level math, it just all boils down to the algebra. Alright, letter B. You guys know what to factor out if you have a fraction? We don't want to have any fractions inside this factor, so I'm going to factor out a 1/5 and then u to the 1/4. I always want to factor out the greatest common factor of 1 and 2 is 1, and I have to take out that denominator in order to not have fractions inside. So what's this divided by that going to be? Just what? 1. Do you know what 2 divided by 1/5 is? 10. And then u to the 5/4 divided by u to the 1/4. U to the 5/4 divided by u to the 1/4. Just u. Okay, so now I'm going to have this 1/5, 4th root of u times 1 plus 10u. And that's our final simplified factor answer. Alright, letter C, getting a little bit more difficult. What's the greatest common factor of 6 and 12? 6, x plus 5. What's the power I would take out? 1/2. So now I have to do this term divided by all of this right here. So if I do that, 6 and 6 cancel. This to the 3 halves divided by this to the 1 half is just going to be what? Just x plus 5 to the first. It's not 1, it's x plus 5 to the first.
Wait, why isn't it?
See, it's x plus 5 to the 3 halves divided by x plus 5 to the 1 half. So when my bases are alike,
2 over 2.
yep, and that's to the first power. So my base stays the same, and that's to the first. And then I have this term that's getting divided, so what's that just going to give us? Plus 2. And so now I'm going to have 6 radical x plus 5 times x plus 7. So these are equivalent. This is just another way of writing that. And it's in factored form, which is more useful when we're doing higher level math. Alright, last one. You guys know what we would factor out here? What did I say we have to factor out? The fraction. So we're going to factor out a 1/3. What about with the 2x plus 5? What power am I going to factor out? 1/4. Okay, so now we have this divided by exactly the same thing. So 1 plus, what's 2 divided by 1/3? 6. And then I have this to the 5/4 divided by this to the 1/4. So what's that going to be? Just 2x plus 5 to the first. And so now simplifying, I have the 1/3. This is going to be the 4th root of 2x plus 5. And then here I'm going to have, I'm going to just simplify this up above, 12x plus 30. And so that's going to be 12x plus 31. Alright?
Oh, you can multiply.
I have to multiply that out and then add on the 1. And so this is another form. And you can see like how different these two look. Like you can imagine doing this complicated problem, you get this answer, you look in the back or at the solutions and you see this and you're like, oh my gosh, I was so wrong. But you're not wrong, just you need to do the algebra. Okay? Alright, good job guys, I know that was a lot. So today, we had all that. You're going to do the